Hey Finxters, welcome back to part 2 of the many magical ways of compromising Linux systems. In today's tutorial, we'll continue on exploring some new ways to root the Linux boxes, and we'll cover tasks 11 through 21. So without further ado, let's get into it. So in today's tasks, we'll be doing quite a bit of copy and pasting, and that's often all you have to do to gain a root shell. So I'll try my best to explain what's happening behind the scenes of each of these tasks. So task 11, we're going to exploit the SUID bit files or executables. So first we'll search with this long find string, looking for any files that we can execute with SUID privileges. This means that we can reset the user to root and gain our root shell. Once we run this exploit that's preloaded to this machine, all we have to do is run the script and gain the root shell. So let me demonstrate that now. In this next task, we'll be exploiting shared libraries, and we can use the strace command to peer into the execution of a file and see that there's actually a library that fails to load because no such file exists. So what we're going to do is create a file with that file name, but make the contents spawn a root shell. So let's set that up now and run the exploit. In task 13, we'll be exploiting environmental variables. So after checking the suid-env file, we see that it's trying to load an Apache 2 service. We can hijack this by using a file titled service that will spawn a root shell, and we'll prepend the path variable with our current directory to make sure that it runs and spawns that root shell. Let's try that now. In task 14, we'll be doing one more environmental variable exploit. This time, we're going to be using a unique ability of certain versions of Bash to set shell commands with file names that appear to be full paths to a file. So let's go ahead and run these commands and see if we can gain root access. In task 15, we'll be abusing a shell feature here. This one only works on Bash versions 4.4 and above, and it makes use of an additional shell which can be created in debugging mode, and a file that we are going to create called root bash, which is a bin bash shell spawning command with the SUID bit, so we can spawn the root shell. So let's go ahead and we'll use persistence with the -p flag to run it with root permissions in a way that we can have a fully interactive shell. Let's try it out. Task 16 is my favorite one here from this whole series. We're going to be examining the history file of command line commands, and we'll be searching for anything with passwords that were entered via command line and saved as plain text. So let's take a look at the .star history, so any file name that ends with history and is a hidden file, and then we'll pipe that to less so we can quickly read those lines. We'll identify that password for the root login, and then we'll go ahead and log into root. And we find out that it is because the command is a MySQL command, so the password is typed in plain text on the command line. In task 17, we'll examine an OpenVPN config file and search for passwords in plain text or in reversible formats, encryptions, or hashes. In this case, it's a plain text password, so pretty easy to grab and then switch over to root. It made me curious to check my own attack box that I use for TryHackMe with ParrotOS, and that OpenVPN file includes encrypted hashes, I should say password hashes, that are hard to reverse, but it's still possible with different tools like Hashcat and CrackStation, the website. So anyway, let's move on to task 18, passwords and keys, SSH keys. So in task 18 here, we're looking for hidden files. We discover a hidden SSH directory, and we can copy that key over to our attack machine and then add the 600 permissions that allow us to SSH with that key. And the -I flag is what we need to use when we SSH with that key into the root account of our target machine. And that's task 18. We just have 2 left, NFS and kernel exploits, and then we'll wrap it up with a little bit of privilege escalation scripts. Task 19 is exploiting NFS. So we're going to mount the network file system to our target box. And to do that, we first need to make a new directory. And I actually had to do this twice because the first time I screwed it up. So I made a different directory name and it worked flawlessly the second time around. We'll go ahead and mount that NFS file system, and we know it's there because we catted out the etc exports file to C, and no root squash was enabled, and that's what allows us to do this as an exploit and create a root shell. Usually when files are created, the ID will be either inherited from the remote user's ID, or if the no root squash is not enabled, it'll be assigned to a nobody user. But here, no root squash is enabled, so it'll be set to a root user. So anyway, let's go ahead with this. We'll create our payload using MSF Venom. It will use the ELF format. Let's add the SUID bit and execution permissions to it. And then back in our target machine, we'll run the shell.elf payload and trigger that rev shell, which gives us the root permissions. The final task here for exploiting task 20 is kernel exploits, and we're going to use a Linux exploit suggester to Python script to first see what options might work. And after we run that script, we'll find out that the dirty cow kernel exploit is probably going to be a way to move forward. So let's go to that dirty cow exploit, and we'll compile it and run it. And what it'll do is actually copy a file with the SUID bit and then create a backup and then put the exploit file in place so that it gets run and spawns a root shell. So again, let's go ahead with this one, and we'll gain that root access, and then we'll look at task 21 briefly. There are 3 different privilege escalation scripts that it asks you to explore and examine. Right now I'm not going to go into that in detail. I may in a future post do a more detailed analysis of different PrivEsc scripts, and so I have a better idea of which ones target which kind of methods and what things are left out and need to be manually enumerated. So anyway, that's it for part 2. Hope you enjoyed it, and I'll catch you on the flip side. Bye.